Good day, viewers. Yeah, welcome back to our mathematics class. Today, we are going to be looking at special angles. That is, angles of 45 degree, 30 degree, and 60 degree. If you are just a new visitor on this channel, try to subscribe to my channel and click the notification bell for the subsequent content. Now, want to look at how to get angles of 45 degree, 60 degree, and 30 degree without the use of calculator. Let's start from angle 30 degree and angle 60 degree. Sin 30 cos and tan 30 degree and 60 degree can be derived from an equilateral triangle. This is a triangle and all the three angles are also equal to 60 degree. So the angle here is 60 degree. This one is 60 degree. Likewise, is 60 degree. So when we sum up the three angles together, it will give us 180 degree. Now, if I try to create a height here and drop a line here, I will divide this equilateral triangle into two parts. It gives us something this way. When I divide this, will be 30 degree, that is half of 60, while this one is 60 degree. Now, I want to know what is sin 30, cos 30, and tan 30. When I'm considering this angle, I will assume this angle is not there. So let's look at it this way. Now, let's consider this part of this triangle. And don't forget, since all the sides are equal, we assume each of the sides is of 2 units. 2 units, 2 units. So if I divide this into 2, I'm going to have 1 unit each here now. 1 unit. So in this case, the base here is 1, while this one is 2. So I want to calculate this side. Let me call it x. Let me call it x. To get this particular side, according to Pythagoras theorem, I can get this side by saying the square of the hypotenuse sides equals to the sum of the squares of the two opposite sides. The hypotenuse is this line AC, that's the side facing the right angle triangle. So the square of it, line AC square, is equals to sum of the squares of the two opposite sides, line AM square plus line MC square, MC square. So here I have line AC to be 2 square equals to line AM, my S square, plus MC, 1 square. So 2 square gives 4 equals to S square plus 1 square, we have 1. Now we collect like 10, 4 minus 1 equals to S square. So from here, my S square is equals to 3. So we square root both sides. When we square root both sides, I have square root of S square is equals to square root of 3. So square cancel square root, x is equals to root 3. So in this case now, my s is root 3. Definitely this side here gives square root of 3. Now, I want to now prove sine 30 degree, cos 30 degree, and tan 30 degree. Now, to prove this, using this triangle that we brought out from this equilateral triangle, so sine 30 degree, according to our SOHCAHTOA, if you could recall, SOHCAHTOA, sine means opposite over hypotenuse. So my sine 30 degree will equal to my opposite here. Let us label this. Since this is our angle, where your angle is facing is the opposite. Since this is your boss 90, where it is facing is your hypotenuse, while the remaining side is our adjacent. Now, what is now my sine 30? Opposite, which is 1, over hypotenuse here, which is 2. So sine 30 degree equals to 1 over 2. Now, cos 30 degree. Cos 30 degree, that is car, adjacent over hypotenuse. So cos 30 degree equals to my adjacent from here is root 3 over my hypotenuse is 2, root 3 over 2. Then tan 30 degree equals to, that is 2, opposite over adjacent. So my tan 30 degree equals to opposite from here, we have 1 over adjacent root 3. That is 1 over root 3. So sin 30 degree equals to 1 over 2, cos 30 degree equals to root 3 over 2, tan 30 degree equals to 1 over root 3. Now, let us now look at the 60 degree. Now, don't forget that in this triangle, if I bring part of it out, this side is 30, this one is 60. I want to consider that of 60 degree now. Using the same right angle triangle, but now we want to consider the 60 degree. To consider the 60 degree, we are going to relabel. Since this is our angle, where your angle is facing now is your opposite. So this is now my opposite. Where the bus 90 is facing is still my hypotenuse. Then this remaining side now becomes my adjacent. Fine. Now what is sine 60 degree? We still remain opposite, so over hypotenuse. That is sine 60 degree equals to my opposite here now is root 3 over hypotenuse, which is 2, root 3 over 2. Then cos 60 degree, that is adjacent over hypotenuse, that is cos 60 degree equals to my adjacent here is 1 over my hypotenuse here is 2. Then tan 60 degree, that is opposite over adjacent. So tan 60 degree equals to my opposite here is root 3 over my adjacent here is 1, which is equal to root 3. Now, this is the derivation of sine, cosine, and tangent of angle 30 degree and angle 60 degree. Now, let's look at the identity that is there. Generally, we can see that sine 30 degree equals to cos 60 degree, which equals to 1 over 2. Likewise, sine 60 degree equals to cos 30 degree, which equals to root 3 over 2. So these are the identities that is in the derivation. The next one is the derivation of sine 45, cos 45, and tan 45 degree. This can be derived from a square. Don't forget a square has all the sides equal. That's a unit of 1. And when a vertical meets with horizontal, we have angle 90 degree. So in this case, when we try to divide it, we want to remove a right angle triangle from here. Taking out the right angle triangle this way, 1 and 1. Let's call this A, B, C, D. So we have B, C, and D. So I want to find the value here. Let me call it Y in that place. Now, using our Pythagoras theorem as well, so we have the square of the hypotenuse size, line BD square, equals to the sum of the squares of the two opposite sides, line BC square plus line CD square. So line BD square is what we are looking for. Let's say Y square equals to BC 1 square plus CD 1 square. So y square equals to square root 1 square means 1 plus 1. Y square equals to 2. So we square root both sides to get our y out. So from here, square cancels square roots. So my y equals to root 2. So from here, this place is root 2. And don't forget, from this upper part, when you try to divide this, taking out a diagonal here, you are dividing this angle 45 degree into 2 equal parts. So we have 45 degree here, we have 45 degree here. So I can now use anyone. If I put 45 degree here or 45 degree, I'm still doing the same thing. So let me put it here, 45 degree. So if this is my angle now, then anywhere facing this angle is our what? Is our opposite. So this is my opposite. Any side facing this box 90 is your hypotenuse, while the remaining side is your adjacent. Let us now prove sine 45 degree equals to, so means opposite over hypotenuse. That is, sine 45 degree is equals to, our opposite from here is 1, our hypotenuse is root 2. 1 over root 2, then cos 45 degree equals to car adjacent over hypotenuse. So cos 45 degree equals to my adjacent from here, we have 1. Our hypotenuse is root 2. 1 over root 2. Then tan 45 degree equals to 2r, that is opposite, over adjacent. That is tan 45 degree equals to, my opposite here is 1, adjacent also is 1. 1 over 1. 1 divided by 1 gives what? 1. From here, we can say generally sine 45 degree equals to cos 45 degree, which is equals to 1 over root 2. So sine 45 is 1 over root 2. 45 also is what? 1 over root 2. So we can use these special angles to do our calculation in SOHCALTUL without using calculator. I meet you in the next class when we are going to be discussing the application of these special angles. I remain Lateef Ismaila Akanbi. If you have not subscribed to this channel, kindly do so and click the notification bell. And do not forget to share to other learners in order to benefit immensely from this channel. Thank you very much.